Hello students, we're going to be starting on the lesson 4 practice problems. I'm going to follow along in your book. This is on page 161. So this is what you're looking at right now. Let's move this kind of up a little bit. There we go. Problem 1. So we got a whole bunch of ones that we have to check out here to see how each one of these, see if they work. This is an artist is selling children's crafts. Necklaces cost $2 1/4 each. Bracelets cost $1.50 each. Select all combinations of necklaces and bracelets that the artist could sell for exactly $12. All right. So let's kind of like look at this real quick here. How are we going to actually do this? Well, we're given some information here, and we can go and we can make a 2-variable equation for this. So what's the information given? They're saying that necklaces cost $2.25 a piece. So we're going to start out with $, $2.25 per necklace. And we're going to say that, let's see, what ones do they give here? They say, well, let's just do a capital N here for the number of necklaces. All right, and then I have to add to that the price of the bracelets, and the bracelets are $1.50 each. So that's $1.50 for each bracelet, and I have to obviously multiply that by the number of bracelets, which I'll call a capital B, and the total has to be $12. All right, so the combination of the two. Of course, the units on necklaces are going to be just that, necklaces, and the necklaces. The number of necklaces will drop out with the unit that we have down here at the bottom of the necklace, and so I'll just get dollars. Excuse me. Bracelets here, it's a number is bracelets, and so the bracelet down here, that unit, and the bracelet up here will cancel, and we'll just get $1.50. So essentially, this thing kind of comes down to 225 times N plus 1.5 times the capital B equals $12. And we have to go and figure out which one of these combinations work. So if we go back to what we got here, 5 and 1. All right, so 5 necklaces, 1 bracelet. Let's do some math here. So 2.25 times 5 plus 1.5 times 1. All right, and so we got to see what this equals and see if it actually works. Well, if you take 5 times 2 1/4, well, 5 quarters is $1 1/4. So 5 times 2.25 is going to be $11.25. And I'm going to add to that 1.5, right? 1 times 1.5. That. Well, you add this up, and you get $12.75. So that first one is a big old fat no. All right, so let's go back to here. And so we got this first one, 5 necklaces, 1 bracelet. No. Okay. And we'll go back to here. Next one, 2 necklaces, 5 bracelets. So 2.25 times 2 necklaces plus 1.5 times 5 bracelets. All right, we're going to see what that equals. Well, 2 times 2 1/4, that's $4.50. Plus 5 times 1.5, well, see, 5 times 5 is a 5. You carry the 2, and you get 7.5. All right. Well, 4.5 plus 7.5, that does, in fact, equal 12. So B does work. A up here does not. Okay, and so this is where we're at the moment. All right. So you can see the 2.25 times 2. And the 1.5 times 5, we're going to be adding the 2, and yes, we do in fact get 12. And let's go and look at letter C here. So you're going to have 2.25 times 3 plus 1.5 times 3. All right, let me get that right. 3 and 3, yep. All right, so let's see what it comes out to. 3 times 2.25, that's 6.75, plus 3 times 1.5, that's going to be 4.5. And that turns out to be 11.25. and a quarter. So C does not work. That's what we've got so far. C doesn't work. All right. Moving on. Letter D. We got 4 necklaces and 2 bracelets. So 4 and 2. And let's see. So we've got 2.25 times 4 plus 1.5 times 2. 4 times 4 and a quarter. Well, 4 times quarters, that's $1. So 4 times 2 is 8. You add 1 and you get $9 there. Plus 2 times 1.5, well, that's a 3, and that does in fact equal 12. So delta does work. Let's go on to Echo. And E states 3 and 5. So I'm going to write those down, 3 and 5. And we'll go to our math here. So we've got 2.25 times 3 plus 1.5 times a 5. Well, 3 times that is $6.75. 5 times that, we did that up above here, and that's still $7.50. Well, let's see. 50 cents and 75 cents, that's a quarter. Carry the 1. And 6 plus 7, that's 13, plus the 1. That's 14, so Echo does not work. Okay. Let's go ahead on Foxtrot. F is 6 and no bracelets. So 6 and 0. And so we're going to have 2.25 times 6 plus 1.5 times a 0. So that one just simply goes away. And we're going to see what that equals. Well, 6 times this, 6 quarters is $50, $1.50. 6 times 2 is 12, plus 1 is $13.50. So Foxtrot doesn't work. It's not $12. All right. Moving on. That was F. And then the last one, which is going to be G. No necklaces and 8 bracelets. So that's 2.25 times, let me go and change it over to camera here. So 2.25 times 0, which goes obviously to 0. And then 8 times 1.5. Well, 8 times 5 is a 40, so that's a 0. You carry the 4. 8 times 1 is 8, plus 4 is 12. So yes, that last one, which is golf, works. So your answers should be B, Bravo, Delta, and Golf. Those are the ones that are going to work. Those combinations come up exactly with $12. Okay. Moving on to number 2. This is Diego's collecting dimes and nickels in a jar. Let me go and switch over here to this other one. There you go. Diego's collecting dimes and nickels in a jar. He has collected $22.25 so far. The relationship between the number of dimes and nickels and the amount of dollars represented is the following. Well, if you look at this thing, the number of dimes times 10 cents, that tells you the number of dollars that you get out of it. And here's your nickels. There's 0.05 nickel is the dollar amount for each nickel times the number of nickels. And let's see if that combination comes up to $22.25. All right. So if you look at this 0.05, ask yourself how many nickels are in a dollar. Okay. So you have to think about it for a while. How many nickels do you need to make a dollar? Well, let's see. You need to make 2 nickels to get 10 cents. If you have 4 nickels, 4 times 5 is 20 cents. If I have 10 nickels, 10 times 5 is 50, or 50 cents, or half a dollar. Well, if 10 does half of the way, let's try 20. 20 times 5, hey, that's 100 cents, or $1. So there are 20 nickels in a dollar. So always kind of remember that. There's 20 nickels in the dollar. So let's go select all values that could be solutions. So I got a 0 and a 450. So that's supposed to be dimes, that first number, and the second number is supposed to be the number of nickels. So let's see if this works in here. All right. So let's go back to our our camera quick, and let's see what we got here. Let's draw a line. 0.1 dimes plus 0.05 nickels equals $22.25. Now the first one that they want us to try is 0 and 445. So I got a 0 and a 445. Okay, and we'll go back to here. Alright, so that's a 0.1 times 0. Well, that's nothing. We just get rid of it. Plus 0.05 times 445. Wow. So if we do a little bit of math here, we could almost do some math in our head on this one. Well, I need 20 nickels to get $1. 20 nickels to get $1. So if I want $2, I'll need 40 nickels. If I want $3, I'll need 60 nickels. Okay, I got 400. All right. So 20 times what number is 400? 20 times 400, or 20, or if you have the 400 nickels, 20 goes in there 20 times. So that's, if you do the math here, the 400 is going to give you the $20. And what's the 45? Well, what's 45 nickels going to give you? Well, that's another couple dollars, right? That's another couple 20s in there. And then 5 more nickels, that's 25. So this actually, when you do the math here, you can either do mental math or you can do it on your calculator. It does actually, in fact, come up to, oops. It does, in fact, come up to $22.25. All right. So if you look at that, that first one does work. All right. So A works. Let's go on to B. What does B want you to do? B is a half of a nickel, 0.5 a nickel, or excuse me, 1/2 of a dime. We don't count half dimes. We don't split dimes. So I'm not even going to bother to calculate this one. This is just screwed up because these have to be integers. All right, integers, integer, 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 da da da, not an integer. I'm not even going to calculate B because I know it's screwed up. This can't be. B definitely is not a solution. I'm just going to go and jump right ahead to letter C. So I got 223 dimes and I got 21 nickels. All right, and so let's go and jump ahead here. So 0.1 plus 0.05. Okay, so whenever you have 0.1, right, that's a tenth. So 223 becomes 22.3. You just simply move the decimal point over. That's all you're doing here. So there's $22.30 right there. Okay. Now you know you're going to have to go and try to get to this number here. So this already is kind of screwed up. So you're already over. But let's do a little bit of mental math. You already know that 20 nickels makes $1. So you have basically $1 and then one more nickel. So you know that this is $1.05, 21 nickels, all right? Or you can even do the math if you want to on your calculator. Well, this obviously doesn't equal $22.25. This equals like $23.35, so it's way off. All right, so C is not going to be a correct answer. All right, so C is out. B is out because we can't have portions of coins. We have to have whole coins. Let's go on to delta. Delta is 118 and 209. 108 and 209. Okay, so let me go and write that out real quick. And so this is what we got so far. We got 0.1 times 108, 105 times 209. Okay, so that's 1/10 of that, so we just move the decimal over, and that's $10.80. All right, how many nickels do I got? Well, if I got 209 nickels, and 20 makes $1, then 200 will make $10. All right, so that's $10, And then you have 9 nickels left over. Well, what's 9 nickels worth? 45 cents. So that's going to be $10.45. Well, you add that up and you go 10.08, 10.80, and 10.45. Let's see, make sure my I made a boo-boo. 10.18, not 10.09. So that's 11.8. Make sure you fix that in your notes. 11.8 plus 10.45, and when you add those together, you do in fact get 22.25. Okay. Sorry about that mistake, but it happens even to the best of us. All right. Let's look at the next one. Excuse me. 172 plus, let's see, we have 110 nickels. Okay, so it's 0.1, 0.05. All right, and let's go back to the camera. All right, so I have 1/10 of 172, so that's going to be $17.20. Nickels, how many 20s go into 100? Well, that's 5, and you got 5 cents left over, which is because of 1 nickel, so that's going to be $5.05. Well, if you add that together, you do in fact get 22.25. So out of this one, your solutions are alpha is correct, delta is correct, and echo is correct. All of those will actually work with this. All right. Okay, and we're on to number 3, which is on page 162. Okay, and let's go back to our number 3. Volunteer drivers are needed to bring 80 students to the championship baseball game. Drivers either have cars, which can seat 4 students, or vans, which can seat 6 students. So they gave you the equation, so let's actually look at that equation, shall we? I mean, it's all fun and dandy to give you the equation, but you should be able to just think and derive it, okay? So let's go and think through this one. I'm going to get over to my camera. All right, so they're going through here, and they're saying that there's cars and then there's vans, okay? So if cars, there's 4 students per car, all right? And I can always, since ultimately I want to have students because I have 80 students that I'm dealing with here. So I want to do a little bit of work here. Reload. So I need to know the number of cars. And I know the vans can hold 6. So that's 6 students per van. And I'll have to know the number of vans. And that adds up to 80 students altogether. So that's where they get this equation right here. 4 times the number of cars plus 6 times the number of vans equals 80 students. The car units cancel the vans. All right, so that's where they get the 4C plus 6B equals 80. All right. So it says select all the true statements. Select all statements that are true about the situation. All right, so let's go through these. All right, if 12 cars go, then 2 vans are needed. Okay, so if I got 12 cars, that's 4 times 12 plus 6 times 2. All right, because that's what they said. If 12 cars go, then 2 vans are needed. Okay, how many seats do we have available here? Okay, so 4 times 12, that's 48. Plus 6 times 2, that's 12. Well, you add that up and you get 60. No, that is not enough. You're about 20 seats short, so no, that won't work. Okay, so A is a bust. It's not going to work. Moving on. Let's see, B is 14 cars and 4 vans. So let me write that down. 14 cars and 4 vans. Okay. And what do we got here? So I got 4 times 14 plus 6 times 24. Let's see, 4 times 14. 4 times 4 is 6. 16, carry the 1. 4 times 1 is 4 plus a 1 is 5. and 4 times 6 is 24. 4 and 6 is a 0. Carry the 1. 5, 6, 7, 8. Well, that gives you exactly the amount that you need. This is exactly the amount. So on B, yes, that one will actually work. So B is okay. Gives you exactly. There's no empty seats going to be on these things. Okay. Well, let's go on to Charlie. It says 6 cars and 11 vans. There will be extra space. Okay. So in other words, what they're saying is, it's okay if you have 81 or more seats. That's okay. All right. So let's see what it says here. 6 cars and 11 vans. Okay. So if I have 4 people per car and I have 6 people per van, 4 times 6 is 24. 6 times 11 is 66. 6 and 4 is 0. Well, 10. Carry the 1. 6, 7, 8, 9. Oh, yeah, you got more than enough room. So that's a true statement. You can actually say that's a true statement. So C is true. All right. They're just asking for true statements here. That's the key to this thing. All right. Select all the statements which are true. And so Charlie is true. All right. On to Delta. 10 cars, 8 vans. So 10 cars, 8 vans. 10 cars and 8 vans isn't enough to transport. We have to select if that's true or not. Okay. So we got a 4, we got a 6. Let me get the camera rolling. Okay. Well, let's see. So 10 cars, 8 vans. 4 times 10 is 40. 6 times 8 is 48. And it says, well, when you add those two, you get 88. Now, the way they worded this, and I'll show you here real quick. Again, select all the statements that are true. Isn't enough to transport all students. Well, this comes out to be 88. There's more than enough. This is not a true statement. Even though that combination will provide you enough seats, the statement is not true. So delta is not a true statement. Okay? So just keep that in mind. Delta is not going to be a true statement. Let's go on to Echo. What does Echo say? 20 cars go, no vans. So 4 times 20 plus 6 times 0. All right. So there we are. 4 times 20 plus 6 times 0. Well, you don't have to be a rocket scientist to figure this out. 4 times 20 is 80 plus a 0. Yep, that's 80. And so Echo does answer the question. It is true. You will have enough students there. Okay. And we're moving on to Foxtrot now. 8 vans and 8 cars are numbers that meet the constraints of the situation. Let's see if this is true. Does it actually meet the constraints? Now here they got 8 cars and 8 vans. So 8 cars, and we have 8 vans. And we want to know if it fits the constraints. So what do we got? Well, let's see. 4 times 8, that's 32. And 6 times 8, that's 48. And so if you add these two together, you do in fact get exactly 80. So yes, this does fit the constraints. All right. So on this one, F works. So you have Bravo, Charlie, Echo, and Foxtrot are all correct answers here. On to number 4. The Drama Club is printing t-shirts for its members. The printing company charges a certain amount for each shirt plus a setup fee of $40. So it doesn't matter how many shirts that you get, 1 or 1,000,000, it's going to be $40 to set up the equipment. There are 21 students in the Drama Club. All right? 21 students. If there are 21 students in the club and the t-shirt order costs a total of $87, how much does each t-shirt cost? All right, so we got to start first. We got to start figuring out what the equation is on this thing. Okay, so let's talk about that. So the print up fee is $40. So you know that they're given are you given a price per t-shirt? No, you're being asked how much does each t-shirt cost. So we can say that X dollars per shirt. That tells me how many dollars per shirt there are, and I have to know how many shirts I'm going to get. Well, I pretty much know how many shirts I'm going to get. I need to get 21 shirts. Alright, so this pays for the shirts, but that's not the only expense. I have to add $40 for the setup. And they're telling me in this particular one, it costs $187. Okay, so that equals 187. So let's take this little verbiage here and let's actually put it into an equation. So 21x, again the shirts cancel, I'm just left with dollars, plus $40 equals $187. Okay, so let's see if we can solve this thing. And the first part that says if there's 21 students in the club and the total is 187, how much does each t-shirt cost? Let's go do the math. Again, I have to use my order of operations, PEMDAS, to go and figure this out. I want to do addition subtractions first. It's the lowest rank on the whole list. So I'm going to do the exact same thing to both sides of my equation. Subtract 40 from both sides. It goes away on this side, shows up over here. And when I take 187 and I subtract 40, I get 147. So 21x equals 147. I need to solve for the x. There's 21 of them. So that's the unknown. That's the coefficient of the unknown. I'm going to divide by that 21. And when you take 147 and divide it by 21, x equals $7 per shirt. Okay, and so that's the answer to that first one, and you get $7 per shirt. Moving on to B, the equation 201.5, that sounds like the total amount is going to be $201.50, equals F, which is the startup fee, the setup fee, plus $6.50 times 21. Well, I recognize 21. That's the number of shirts that we're going to need. $6.50 sounds like that's the price per shirt. So rather than $7 per shirt, now we're talking $6.50, and you got a bigger number here changed. Represents the cost. Find the solution for the equation. State what it is that represents in the solution. Okay, so we're looking at this little thing right here, the setup costs. That's what that thing. That's the setup costs. All right, you're not multiplying by everything. It's just that's how much it's going to cost to set up the equipment, colors, design, etc. All right, so what do we got here? We got an equation, and I'm going to rearrange it just a little bit so it's a little bit more familiar. They've given it to you this way. I'm going to set it up like this: 6.5 times 21 plus F equals 201.5. Okay, so I'm going to set it up like that. That is a little bit more conducive to what I want to do. So I want to solve for F. All right. I can go and knock this out because that's a number times number, and so it just is a number. So let's make ourselves easier. 6.5 times 21. What are we going to get out of that? That's going to be 136.5. 136.5. All right. Plus F equals 201.5. All right. Again, I'm solving for F. I don't have any. I just need to start out with PEMDAS, the low end of the board. And so what am I going to get out of that? And let me go and pause it here. I've run out of leads. Okay, and we're back. So as you can see, we left off at 136.5 plus F equals 201.5. I've got to solve for F, and there's this addition between, so I have to undo a subtraction. So I'm going to start by subtracting 136.5 from each side, minus 136.5. And when you do the math, wink, wink, you just have an F on this side, and the 50 cents obviously cancel. And so when you take 201 and you minus 136, you get 65. All right. So what's that? That's $65, and that's the setup fee. All right. That's what that means. All right. And we move on to our next page. Okay, so a little bit of review. The box plot represents the distribution of the number of children in 30 different families. Okay, so the number of children. So they start anywhere from 0 and they go all the way up to 12 kids in one family, with 50% of them represented between 1 and 3. All right, so if you just look at this thing, let's just look at this. So what's the IQR on this thing? Well, it's going to be 3 minus 1, so that's 2. So that's a pretty tight band there, and that looks like there might be just like one family out here with 12 kids in it. Okay. Upon further examination, the value of 12 is removed for having been recorded in error. Somebody's happy about that. The box plot represents the distribution of the same data set, but within the maximum 12 removed. So that last, there was just one errant number of kids in the family of 12. And so they took that out and whoop, it dropped down to here. Okay, so that means that there's some family with 6 kids. It's still a lot. Okay, so that's what happened there. So now they start the questioning sequence. The median is 12, or is 2 kids, 2 children for both plots. Okay, so this thing didn't really change up here. Just, this thing, the median still remained the same. All right, and even though you took out one of the outlier. Explain why the median remains the same when 12 is removed. Well, obviously, removing the outlier didn't change the middle number or the median. All right, so what happened was there's probably a whole bunch of people that had 2 kids, and so they just moved from like between 2 numbers to onto one of the numbers, which is 2. So there must be a whole bunch of people out there with 2 kids. When 12 is removed from the data set, does the mean remain the same? No. Remember, the mean, you have to add up all the information and then divide by the number of samples. Well, if you take out some of that, you're going to get a different number, and it's going to, when you divide, you're just going to get a different number because you're doing math on a different set of numbers. So no, the mean is not going to be the same. And in fact, the mean will be less because the larger number was taken out. It moves the whole thing back. This thing skewed it to the right, and so you moved it. Once you got rid of that, now you have a little bit tighter nesting of the information. Number 6. Let's see. The number of points Jada's basketball team scored in their games have a mean of about 44 and a standard deviation of about 15.7. Interpret the mean and standard deviation in the context of Jada's basketball team. Well, the team's average is 44 points, but the high standard deviation suggests they score anywhere from 15.7 points above and below the mean. So here's your mean at 44. Okay, so if you go up 15.7 units, now you're up to 59.7. And if you take off the 15.7 points, well, now you're in the high 30s. Okay, so anywhere from 30 to 60 points. Yikes. So there's a big old standard deviation that's going on here. Let's see. 44 minus 15.7. There's a 0 there. 10 minus 7 is a 3. And we'll borrow from that. 13 minus 5, that's an 8. And that becomes a 3. So that's 38.3 right there. Yeah, you got a big old, look at that. Look at the amount of slop that you got in that thing. Oop, not 30. That was a 3. 20. 28.3. My bad. So yeah, you got about a 30-point slop there. Yikes. That's all over the place. Kieran's family was having people over to watch a football game. They planned to serve sparkling water and pretzels. Wow, how festive. They are preparing 12 ounces of sparkling water and 3 ounces of pretzels per person. And these people are eating like birds. Including Kieran's family, there will be 10 people at the gathering. 10 people altogether. So 10 people, they have 12 ounces of sparkling water per person, 3 ounces of pretzels per person. So, yeah, bottle of sparkling water costs 22 cents. Let's see, contains 22 ounces and costs $1.50. Package of pretzels has 16 ounces and costs $2.99. Holy cow, they got a lot of information in here. Jiminy Christmas. Let N represent the number of people watching the football game. S represents the sparkling water. P represents the ounces of pretzels. B is the budget. Yikes. Which equation best represents the budget? Okay, so let's go through this thing. All right. Now you can look at these and try to figure out what's going on. It might be best just to go through and try to figure out what these people are talking about. Okay? So ultimately we got to figure out the budget, right? So we want our answer in B, in budget, in dollars, okay? So let's look at this thing. So what do we got? They're telling me I got dollars here. So I know they got $1.50. What does the $1.50 get me? It gets me 22 ounces of sparkling water. So 22 ounces of sparkling water. Okay. Now they continue on and they say that they figure 12 ounces of sparkling water per person. So 12 ounces of sparkling water per person. Now you notice how I represent that? I got ounces of sparkling water here and I got ounces of sparkling water up here. What's the units at this point? Dollars per person. What do I need to multiply this thing by now to get? All right, well, there's how many persons are there? Well, there's 10 people. All right, 10 people. All right. Oh, that's just the sparkling water. Okay, persons cancels. Now I'm back in dollars. Dollars over here, dollars over here. All right, I'm on the right track. Okay, so plus. I can kind of mimic this for the pretzels. What's the pretzels at? Well, the pretzels are $2.99 per 16 ounces. 16 ounces, and I'll go pretzels. P-R-E-T. All right, what am I? Okay, so I got dollars. I need to get rid of the ounces of pretzels. How many ounces of pretzels do I get? All right, well, everybody gets 3 ounces of pretzels per person. So 3 ounces per person. All right, so ounces of pretzels cancel. Now I'm dollars per person. I need dollars. And again, how many people I got? Yeah, I got 10 people. 10 people. People's canceled. Okay, so I've got all these numbers. I've got B equals 1.5 times 12 times 10. It's being divided by 22. Okay, and is anything else there? That looks like that looks like about everything. Let's look at this little bottom part here. It looks like plus 2.99 times 3 times 10 divided by 16. So we got a whole bunch of numbers here going on, and that should tell me the budget. Okay, so we got some ideas as to what we should be looking for now. All right. Well, let's see. What's the budget here? Okay, 12 times S. Well, 12 is 12 ounces of sparkling water, and S is ounces of sparkling water. No, that's 12 ounces of sparkling water, and that's the ounces of sparkling water. So the units don't even work here. What's 3? 3 ounces of pretzels per person times P, which is the ounces of pretzels. The ounces, it's just all ounces. There's no dollars in this thing. It's all jacked up, so that's out. 12 times 10, 3 times 10. So I can see 10 people. And let's see, 12. What's the 12? 12 ounces of sparkling water per person. So that's sparkling water. That's ounces of sparkling water so far. Times 10 persons. So that's just ounces of sparkling water. And the 3 is 3 ounces of pretzels per person. So that's ounces of pretzels. That doesn't equal my budget either. Okay. What about here? 1.5 times S. Well, what's 1.5? 1.5. All right. And S is, let's see. S is ounces of sparkling water. So I've got dollars times ounces of sparkling water. So yeah, this one will cancel out, and you'll get dollars out of it. That will work. And then 2.99 times P. So 2.99 is dollars for 16 ounces, and P is the ounces of pretzels, so that will cancel out. So this one will actually work. You'll get something along here. This is like the amount that you're going to have per person. All right, but this doesn't. This is just like it will work, but not the best if you want the total amount. And then down here, what do you got? Well, you've got 1.5, you got 2.9, you got 6. What's S supposed to be? Represents the ounces of sparkling water. We need more than 6 ounces of sparkling water. I mean, if you got 12 ounces of sparkling water per person and you have 10 people, you need 120 ounces. So that's jacked up. And then this 299 times 2, 299. That's the cost of pretzels for every 16 ounces, but then you multiply it by 2, which is, I don't know, let's see where the 2 went from. Is there a 2? Let's see, 12, 3, 10, $1.50, 22. I'm not sure where the 2 comes from, so, nah. I mean, the only thing that we really have here is like this one is kind of close, but it's almost per person. My calculations actually come up with a dollar amount, the total. They're probably talking about the budget per person. That'd be my guess. So this one is the closest. I'm not exactly happy with it, but it's close. It gets you in the ballpark, but there's still more calculations to be done on that number 7. So I'm not really too pleased with that answer. Moving on to number 8. The speed of an object can be found by taking the distance it travels and dividing it by the time it takes to travel. Okay, stop. Let's look at this. What are they actually talking about? They're talking about dirt. Distance is rate times time. Dirt. Okay? Now we can rearrange this. Right now it's solved for D. I can solve it for rate, and I can solve it for time. All right, let's solve it for rate. If I want to solve for rate, get rate all by itself, since I'm multiplying by time, I'd have to divide both sides by time. So I'm going to go divide by time. If I divide this side by time, I just get the R on that side. If I divide this side by time, I get a distance divided by time. Oh, okay. And on this side, if I want to solve for time, since I'm multiplying by rate, I have to divide by rate. So this time I divide by rate in this way. Divide this side by rate, I just get T. And then what do I get on the other side? Well, now I get distance divided by rate. Okay? So you can go and have 1, 2, 3, depending if you want to solve for distance, rate, or time with this one equation. Okay? Now what are they actually going through here? What are they actually asking you? It says the speed of an object can be found. The speed of an object can be found. The speed, the rate. All right? The speed of an object can be found by taking the distance it travels and dividing it by the time it takes to travel that distance. Now I understand where they're coming from. An object travels 100 feet in 2.5 seconds. Okay, 100 feet, that's 100 feet. All right, there's your distance. And 2.5 seconds, there's your time. 2.5 seconds. That, of course, equals your rate or your velocity or your speed, however you want to say it. Let the speed S be measured in feet per second. Feet per second sounds good so far. I mean, all my units are lining up. Well, how many times does 2.5 go into 100? Well, if it was 25, it'd go in there 4 times. But since it's 2.5, it goes in there 40 times. So 40 feet per second. And that's your rate. Okay? So they go through there, and that's what you kind of get, 2.5. So they got a whole bunch of math that's going on there. So I like a rate of 40 feet per second. All right. And number 9. Donut shop made 12 dozen donuts. 12 dozen. What's a dozen? Is 12. 12 donuts per dozen. And they made 12 dozen. Dozens cancel. I made 12 times 12, which is 144 donuts. All right. Which expression represents how many donuts each student would have to get if the donuts were equally distributed amongst 12 or X students at the math club? Well, you know how many donuts you have, right? You know how many donuts? You got 144 donuts. And they're asking for how many donuts would each student get? They're asking for donuts per student. That's what they're asking for. Well, you know how many donuts there are. There's 144 donuts. And let's see. And there are X students, so X students. There. Now my units match what I'm supposed to be looking for. Let's see which one of the answers correlates with that. No, that's students per dozen. 12 times 12, hey, that's 144. That's pretty close, okay? So that's donuts per student. That one works. This is like donuts times students. Student donuts. No, the units don't even match up. And then 12 times 12, that just tells you the number of donuts you got. That's it. But it doesn't tell you how many donuts per student. So that's out. So the only answer there is going to be letter B. And that is the end of the review, the practice problems for this section. And so we'll move on to our next section after this.